What's up, guys? This is lesson 2 in Unit 8. We are continuing on with talking about trig ratios that we started last lesson. So remember that sine, cosine, and tangent, and trig is just a branch of math, like geometry, algebra, there's trig. So let's remind ourselves before we jump in to learning more trig, what the acronym was, SOHCAHTOA, that helped us remember how you set up these different trig ratios to find your missing pieces in a right triangle. So it's SOHCAHTOA, and the SO helps you remember how to set up sine. So sine, it looks like sin, but it's sine. The sine of some angle, we'll call it A, so sine is opposite over hypotenuse. It's the opposite leg over the hypotenuse. And then in the middle, that's cosine. So the cosine of some angle, we'll call it A again. Cosine is adjacent over hypotenuse. So kind of follow the letters here. And then the TOA, that's to help you remember tangent. Should have spaced these guys out a little bit. Tangent is opposite leg over adjacent. Hopefully my abbreviations you're cool with. So basically, like I said, this is just a continuation from last lesson, lesson 1. The only difference between lesson 1 and today is that the variable we're solving for when we set up our trig function here, it's now an angle instead of a side. Okay, yesterday we found missing side lengths and that's it. Today we're finding missing angles. So it's going to feel really similar. The only difference, and we got that here noted, the only difference is how we plug it into our calculator. So please tell me you have your calculator. If you don't, pause it and go grab it. You'll want to follow along with how I'm punching this in. If you can't plug it into your calculator, you're never going to get it right. Okay, so a few examples. I think there's 4 of them. Let's just jump right in. Now, I've got steps here, just like I did last lesson. I feel like that hopefully is helpful on how to walk through the problem. But my goal is just to find each variable. I'm going to round angles to the nearest degree. So if I'm solving for an angle, nearest degree, that means whole number. 65 degrees, 42 degrees, okay? Whole numbers for your angles. Segments, they're asking me to round those to the nearest 10th. So that's 1 decimal place. You will get dinged for not paying attention to details like that come quiz and test time. Got to pay attention to details in life. Okay, so number 1, the steps start out the same. Again, everything's going to be the same except for step 3. So this will be a good review of last lesson. Or if you were really good with last lesson, this should be a breeze. So first step, in my opinion, is to label the sides of the triangle in relation to angle X, or if they call it W, Y, whatever. This angle that is labeled here, whether I have it or not, I'm going to label the 3 sides of the triangle in relation to that. Pick out the hypotenuse first, every time. Okay, across from the right angle, that's your hypotenuse. Across from your angle that's labeled, or in this case, the one I'm trying to find. If I draw an arrow away from that, this side right here, that's the opposite leg. That makes the one right next to it right here the adjacent leg. Okay, step 1, done. Label the sides. Step 2 is determine which trig ratio is going to work here in solving for X. So think SOHCAHTOA. Now, you always ignore the side length that has no label on it. This side is labeled 5. This side is labeled 8. The hypotenuse, no label. There was nothing there at the start of the problem. So I'm not using the hypotenuse. I'm just using adjacent and opposite. So that's tangent. Tangent uses opposite and adjacent. So that's the trig ratio that I want to use. Okay, so here's how I set it up. And I'm going to follow, let's look at that. I'm going to follow this setup right here. So the tangent, this is step 3. The tangent of the angle. We always had a number there yesterday, but now we don't know the angle. So I'm going to say tangent of X. The label on the angle that should equal the opposite over the adjacent piece. So opposite is 8, adjacent is 5. Okay, so we're just trying to figure out here what angle in a right triangle always has the ratio of 8/5 when you take the opposite over the adjacent leg. Such like a vague concept, like a deep math concept, but that's what we're saying here. So here's now where I take it to my calculator, and here's how you plug this in. This is almost like way easier than finding a side. So all you guys are gonna do above the sine, cosine, and tangent button, hopefully you have a calculator. Most of you have a calculator like mine. If yours is different and you can't find these buttons, I will show you tomorrow, or just like flag me down and say, hey, can you show me where these buttons are? Okay, so above sine, cosine, and tangent, see how it says like sine -1, cosine -1, tan -1? That means inverse. You use that to find the angles. So here's what I'm gonna do. I'm gonna do tan, obviously. Inverse tan is how you say this. And then I just type in that fraction, 8 divided by 5. Whatever it spits out, that's my x value. So watch. Since I want to get that tan -1, which is above the tan button, you press second tan. Second tan. Ooh, that's hard to see. And then it'll show tan -1. So inverse tan is what you use to find the angles. And then I just type in 8 divided by 5. And I know I want to round angles. This is an angle to the nearest whole number. So I'm going to bump that up and say 58 degrees. Short and sweet. Once you get the SOHCAHTOA part down, short and sweet. All right, let's do the next one. So again, I want to start by labeling the sides. Across from the 90, that's the hypotenuse. It has a label this time. All right, I want to label the legs in relation to the angle that is labeled on the picture, which is x this time. Across from x, that's going to be our opposite leg. The one next to it, that's the adjacent leg. And the adjacent leg has no label, so I'm not using that one in this case. I want opposite and hypotenuse. Don't be freaked out, you guys, that has a square root there. It's just a number. So opposite and hypotenuse, that's sine. Opposite over hypotenuse. So there's some angle measure that when you do opposite divided by hypotenuse, it always equals the same fraction, the fraction I'm about to write. So I just need to find out what angle is this. So I'm going to do sine. Again, it's helpful to see it. So I'm going to say sine of the angle, which in this case is x, equals the opposite piece, 11, over the hypotenuse, square root 170. When I'm finding the angle, I type it in inverse sine, or sine -1, and then I just type in that fraction as like a division problem. So same deal. If I want the -1 sine, I have to press second sine, and then I do 11 divided by, to type square root, you do second x squared, at least on my calculator, and then 170. You don't even have to close the parentheses at the end like I did, but I'm an overachiever, obviously. Oh, weird. Nearest whole number, that's 58 again. Isn't that fun? If you have a weird calculator where it doesn't show you everything that you're typing, mine shows me everything that I'm typing as I type it in a line. If yours doesn't do that, you might have to type it in backwards. But again, if you have a different calculator than mine and you're not figuring it out, just flag me in class next time and I'll show you how to work your calculator. Okay, I've seen them all over the years. All right, number 3, I want you guys to try it. Do your work, answer the question, make sure you get the correct answer down in your notes. And I'm going to end it with number 4 here. So 4 is a little different because there's actually a couple triangles drawn in here. Remember, and I will tell you this a million times, but I always write SOHCAHTOA at the top of my paper. It's going to be on the board probably, so reference that. SOHCAHTOA only works in right triangles. So if you looked at this whole triangle, take that out, that's not a right triangle. that tells me I either have to look at like this triangle or this one. There's a right angle right there. I can't do SOHCAHTOA on the whole thing because there'd be no hypotenuse, there'd be no opposite and adjacent leg. So I just have to think to myself, which triangle do I look at? Well, I need to look at the one that has more information. There's only one number on that triangle on the right. So I'm going to start at the one on the left because I have 6 and 10 over there. And my steps are the same. I'm going to label the different sides. So across from the 90, that's the hypotenuse. I'm looking at angle W right there. Across from that, 6 is the opposite leg. And then that makes this other piece the adjacent leg. Do not even look at that triangle on the right there. All right, I'm going to set up SOHCAHTOA. So there's no label on the adjacent. So it's opposite and hypotenuse, which is sine, O and H. So I'm going to do sine of the angle equals opposite over hypotenuse. If I'm finding the angle, I do second sine, 6 divided by 10. So that's going to give me, and I'm still thinking like nearest degree, nearest whole number, that's going to give me 37 degrees. Okay, so I have W. Now take a look at your picture. So this is 37. See how these guys are marked congruent? Or that's what that's supposed to mean. Those angles are marked congruent. So that means that this is 37. Okay, so now I can look here, and I'm going to ignore that label there. Now I've got, and if it helps you to redraw it, maybe do that. This is 37. This is X. This is 6. I'm going to start over. This is like a whole new problem. I'm going to label my sides for this triangle. So across from the 90, there's the hypotenuse. Across from the 37 degrees, that's the opposite leg. And then this other one, adjacent. Okay, don't just use the label from the other side. 6 is no longer the opposite leg. It's now the adjacent leg because I'm looking at that top angle 37. That will change. Okay, I'm not doing the opposite here. There's no label. So it's adjacent and hypotenuse, which is cosine, adjacent and hypotenuse. So to solve for X, I'm going to do cosine of my angle, 37. Cosine is always adjacent over hypotenuse. So 6 over X. This time I had the angle, you guys. So this is actually a problem from yesterday where I'm finding a side length. So if you didn't catch on to this from yesterday, and you don't have to do the cosine -1 anymore. You only do the -1 when you're finding the angle. I'm finding the side. I don't know if you caught on to this or if you heard me say it, but when the number's on top, you always just do 6 divided by cosine 37. That's how you'll put that in your calculator. Here's why, and I just think of it like this, like I multiply the X over, so then it's like X times cosine 37 equals 6, and then I divide by cosine 37. Not the prettiest of work, but same deal, 6 divided by cosine 37. I feel like you'll do this enough that you'll remember, okay, when the number's on top, you do number divided by cosine blah, blah, blah. So that's how I'm going to type it in my calculator. No second cosine. When you have the angle, don't do that. And they said on the front nearest 10th, so that's going to be 7.5 would be my X value.